fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental mathematical relationships. That math class can be less like it has been for so many of us and more like mathematicians working together. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
In this episode, we are continuing the conversation about models and modeling. The idea that we use those words to mean lots of things, but that we need to parse out and be more particular about what we're saying so that we can understand each other and therefore make more progress and making more math more figure-outable.
Ta-da!
So Pam, last week we talked about a variety of meanings for the word model.
Yeah, and the most important takeaway is this important sequence of modeling.
Yeah.
First, it's sort of a model of the situation. As kids are in a context, we want to be able to model that situation, really understand what's happening. But it's an important model of that situation because then that model of the situation then sort of morphs into where as the students are solving problems, then the teacher represents their thinking, that we make a model of their thinking, make the thinking visible. And as the teacher makes that thinking visible, as students say, when my brain does that, it could look like that. Then we transition to have students then use that model to represent their thinking. Then we ask students, hey, when your brain does that, could you make that visible? How could you show me your thinking? But that has to come after we've sort of used a model to represent their thinking, giving them ideas of how they can represent that. And then lastly, after lots of experience and really using that model a lot to represent their thinking, then that becomes a tool for thinking. Then they can actually use that model in order to think. And so that's kind of this really important sequence or progression of modeling that we like to think about when we work with teachers. Now, Kim, there are some popular progression videos out there. And when I just said progression of modeling, you're like, oh yeah, I've seen some progression videos. Those are cool. And they're very well made. And they sort of show a progression of manipulatives through the grade levels. And they end with, voila, that's why the algorithms work.
Yep.
They're really well done and they're entertaining and they do explain well the algorithms. And maybe many people understand the algorithms for the first time because of these progression videos, which might be noteworthy about the usefulness of understanding the algorithms. Just saying. So you might find it interesting that we don't promote these progressions because remember, the algorithm is not our goal. Nope, not our goal. So today, I'd like to discuss another reason that we don't promote those progressions. And it's about the way those videos use manipulatives. So today, let's focus more on one of those things we said in episode 58 that we don't mean. We do not mean when we use the word model. When we talk about how important it is to use models in math class, in math teaching, we don't mean manipulatives. At least carte blanche.
Oh, manipulatives. So I was on Facebook recently and, I keep seeing these posts, lots of posts in different teacher groups about people changing grade levels or starting teaching. And they're asking things like, what's the best manipulatives that I need for this particular grade level? Y'all give me some ideas. Or, I got a couple $100 as a new teacher and I'm trying to hear from others what manipulatives I should get. What do you recommend? And I find that so fascinating that that's the question that they're asking.
Yeah, like Kim. Let's talk about manipulatives. Give us
Yep.
some examples of what we mean. We got high school teachers on here. What do we mean by manipulatives?
Oh, there's so many, right? So there's base 10 blocks. We've got counters. We've got two-sided counters. Little colored teddy bears, maybe in younger grades.
Cute.
Yeah. There's unifix or centimeter cubes, dice, little clocks, tiles, algebra tiles, hundreds charts, student size hundreds charts, all the things, right? To get students holding, moving, manipulating.
Manipulating. That's why they're called manipulatives, right?
Yep.
Stuff that they can sort of move. And all of that is in the name of helping students feel the math,
Yep.
do something with the math, experience the math. But ironically, not in the way that we mean, at least much of the time. All right, so a quick story. When I was a new teacher, brand new teacher, I think I was in my like third year of teaching, I read a really well written, well said president's message from NCTM President Gail Burell. Y'all, she is one of those people who has really impacted the way I think about teaching and learning mathematics. And not just from this really well written president's message, but other. In fact, I'll give a shout out to Gail Burrell. I used to tell people when I would talk about going to conferences, I would say, hey, when you go to conferences, don't look at the session titles, go to the speaker index and look at who's speaking. Choose who you go listen to by who's speaking. And I would flat out say there are 5 people that it doesn't matter what they're talking about. I will go listen to those people. Even if I've heard them before, I learned something new from those 5 people. And Gail Burrell was one of those 5. I have learned so much from her. And y'all, it's 5. It's just like a short list. Now that list has changed over time. You might be interested someday. Hey, someday maybe we'll do a podcast episode where you can ask me who my current list of 5 people are. Not today. So in that president's message, the specific one that I'm thinking of. So this is a few years ago. When was Gail president? This might be in the 1990s, I think. She wrote this president's message. Y'all, do you remember the old Wendy's commercial? So I'm dating myself a little bit, but there was a Wendy's commercial that was, "Where's the beef?" And it was this little old granny, and her little spiel was, "Where's the beef?" Because like Wendy's had more beef in their hamburgers, whatever. And so it was this, like a lot of things at that point in time kind of took off on that slogan. And it was this, "Where's the beef?" Kind of thing. Well, Gail, as the NCTM president, said that she'd been traveling around the country in her role as being NCTM president. And she was in all sorts of math discussions and classrooms, and she was seeing many, many manipulatives. But she worried if the mathematics were missing. And
Yes.
ready, the title of her president's message was, "Where's the math?"
Yeah.
And I remember like, "Where's the math?" And I remember thinking, but isn't that what we're supposed to be doing? Like, isn't it all about, because I was big into like CRA, and are we supposed to be making it concrete, right? Because manipulatives, they embody the math, right? Or do they?
Yeah, that's so good. So let's describe a little bit of what she might have been seeing, right?
Mhm,
So like let's say it's time to be working with negative numbers. And so we'll see teachers take out integer chips, which
mhm.
are counters that are red on one side and yellow on the other. The CRA approach would have kids build the numbers and talk about zero pairs, and then the kids start moving tiles around. And then the teacher has kids draw the same things, and then the abstract, right? Then they write the numerals.
Yeah, CRA, concrete, and then the representational and the abstract. Well said. That is a way, not so much what we suggest. So then what are we suggesting? What does it mean to do kind of more of what we are talking about? Let's do that with these integers, with positive and negative numbers. So we suggest starting from important contexts, because the first step in the we recommend is a model of the situation. And so we want to help kids really think about temperature and elevation and debt and even American football. So I know we have lots of international listeners, and so American football, not soccer, because we have this line of scrimmage thing. So if you're not a big football person, you can probably leave out football, but that one works as long as your 0 is the line of scrimmage. We don't want 0 to be the 0 yard line on the football field. So what do? We talk about temperatures that rise and fall and are above 0 and below 0. We talk about elevation above sea level and below sea level. We talk about debt, and we're sort of in the black and in the red, and what that all means. And we ask kids really good questions, and we let an open number line be a representation of the situation, of the context. So, sort of our kind of beginning modeling sequence is that we use an open number line to represent the sequence. And then we ask kids really good questions. And as they think and reason about falling below, like I was 10 feet above sea level and then I fell down in a cave and 20 feet. And so where am I now? And as kids think about that, or, hey, we're in crazy Texas where this, this last winter, it was 32 degrees, which is cold for us. And then all of a sudden it was like 7 degrees. And so how far did it drop? And as kids reason about that, or like when I lived in Michigan and it was 2 degrees above zero and then it was 10 degrees below zero. Kidding? No, I'm not kidding. So we have kids reason about those situations. We model their thinking. We represent it on an open number line. So as they sort of think about, oh, well, then it would mean that I dropped then we write that as minus 10, or we have an addition of a debt, then we write that as plus a negative $50 if that was our debt. And so we represent those negative numbers and those movements on that open number line. We represent those things. We represent their thinking. And then we ask them, hey, now that you've seen me represent your thinking, can you represent your thinking using this number line? And then with lots of experience and lots of nudging, we help kids then move to where that open number line becomes a tool for them to reason with about negative and positive numbers, about integers. So I'm going to quote Kathy Fosno, who said, "The mathematics is not in a model to be seen. The mathematics is in a child's mind. You can't just hold up a visual picture and expect that children see the mathematics in that model." Unquote. Y'all, you might listen to that again. It's like really important we think that the manipulative embodies the mathematics, but it's only because we understood the mathematics enough to create the manipulative. We need students to build that mathematics in their minds. It's not just embodied in that physical thing. We can't just hand them the physical thing and expect the mathematics to magically happen. Another quote by Hugo Gravemeyer is that the materials cannot transmit knowledge. The learner must construct the relationships.
So good.
And we agree.
Mm-hmm.
So let's talk about contexts. You might notice that I use some very specific contexts for integers. They need to be contexts that translate, in this case, to number lines. So it's not just about any random context to get kids interested. Sometimes people hear, oh, you've got to make it real so kids are interested. It's not about that. It's not about real world. It's about contexts that make the mathematics realizable. And then we can translate to those really important models. So again, the sort of modeling that we think about is that it's first a model of the situation. Then the teacher models student thinking so that then students can model their own thinking. And then we transition, and this takes time and experience, to a model for thinking or in order to think.
So if listeners, if none of this makes sense, right, think of an analog clock.
Mm-hmm.
The math is clearly in that clock. You and I know that, right? What the numbers represent and what's going on. We've already messed with those relationships in time. But do kids understand that analog clock by looking at it, or even messing with one where the hands move? Or do they need to have experience with the relationships? Absolutely. Just having that manipulative does not ensure. We can't just hand it to them and ensure that they understand time. So,
especially if we just hand it to them and say, now do this and now do that.
Right.
And you got it down. Okay, you got those little steps. Yep. All right. Now you understand time. What?
Yeah. So are we suggesting that manipulatives are bad? Absolutely not. But we so want to be particular about which ones and how and when we use them. Mm-hmm. And in the next few episodes, we're going to take a bit of a deeper look into what we do recommend.
So, if you want to learn more math and refine your mathematics teaching so that you and your students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable.